Okay, in this presentation we're going to look at confidence intervals, and in this question we're going to look at a 95% confidence interval. We're going to calculate a 95% confidence interval. A sample mean of 500 claim amounts, so that's n equal to 500, which is a large sample, results in a mean of $237 and a standard deviation of $137. Calculate an approximate 95% confidence interval for the true mean claim amount for such claims, explaining why the normal distribution can be used. So in this case, what we're going to do is just get a sort of general setup of a confidence interval. Now this is my own little sort of construction of, in terms of how to explain it. Point estimate plus or minus quantile times standard error. So essentially you have to remember that we're actually calculating two values, an upper bound and a lower bound of an interval. And that's why we have that plus or minus there. Okay, so there's actually two calculations. And that's the general structure there. So the component parts are the point estimate, which is either a sample mean or sample proportion. Okay, quantile, which is a number that sort of scales the confidence interval according to the required confidence level. In this case, if it's 95%, there's a particular number that you would use as a quantile, depending if it's a large sample or a small sample. And a standard error, which measures the dispersion of the sampling distribution for a given sample size n. So this part here, I'm not going to spend so much time on here, but explaining why the normal distribution can be used. Now this is essentially based on sampling distributions, which is something, it's a bit of theory that you should know. Okay, and a key thing that you should know here, I'll actually just write it down here, is the central limit theorem. Okay, so essentially this question just asks you, really just mention something to do with the central limit theorem. And also actually just a sort of another thing that it's essentially, it's the sampling distributions, which is if you take a sample and get a particular sample value infinite number of times, that distribution should be normally distributed. Okay, now and also just actually sort of helps to point out for it's particularly for the case of large samples. So I have little tables here, and I just realized actually quickly that this bit is wrong. It's alpha probability of z greater than the quantile is alpha over 2. So I just messed that up there. Okay, so for example, the probability of z being greater than 1.96 equals 0.25. That's okay, 0.5 over 2. Anyway, so what we're looking at here is 95% confidence interval, which means an alpha of 5%, significance level alpha of 5%, and a bit of tables work should give you 1.96. Okay, now another quick remark here is that the standard error, sorry, I forgot to put in the standard error formula here. So the standard error for a sample mean is SE, the standard error of x bar is sigma over the square root of n. Okay, so that should be on your formula sheet. Really at this stage you should be fairly familiar with it. Now, but if sigma is unknown, use the sample standard deviation S as an estimate. Okay, and you know, it helps to put in something like that to just show you really know what you're talking about. Okay, so point estimate here is x bar 237, so it's a large sample, 1.96. That was straightforward. Large sample size, and the standard error is below. Okay, actually the matter of it being a large sample size is sort of redundant at this stage. I sort of mentioned it there, but anyway. So the standard error is 137 over the square root of 500, which is 6.1268. And when I multiply that by 1.96, so essentially I'm just piecing everything together here. Point estimate plus or minus quantile times standard error. 237 plus or minus 1.96 times 6.128. So we multiply those first, and then add or subtract from the point estimate. Now that works out to be 12, so it's 237 plus 12, which is 225 to 249. So that's our confidence interval. A little sentence at the end the confidence interval for the true underlying mean claim amount is such and such, 225 to 249. Just a little sentence like that at the end is helpful, particularly if you're dealing with thousands or tens of thousands, and you just, you're working in units of 1,000. Basically, you go for the A1 answer, just put in a little sentence like that at the end. Okay, so we'll leave it there.